Let's take a look at how to solve logarithmic equations. Now, since it is just solving equations, I already have our steps up there, but let's take a look at what we mean by a logarithmic equation. Let's say we have some directions here for today. Solve. Let's say if I had log base 3 of x plus 2 is equal to, 2 again. Keep the number small. All right, so this is a logarithmic equation because we have our variables inside a logarithm. So somehow we're going to have to get rid of the logarithm. The basic idea for this is we're going to convert to the corresponding exponential equation. We've seen how to do this in the past. So if we have a log statement, remember the base of the log is the base of the exponential. The answer to a log is an exponent, so that goes up top, and the argument is what it equals. So we need to be able to go from a logarithmic equation to a corresponding exponential equation. Now to get to here, we're going to have to get all of our logs together. So here's what our steps tell us to do. We're going to move all the logs to one side and everything else to the other. Once we have all our logs on one side, we condense it into a single log, so we end up with something like this. Then we're going to convert to the corresponding exponential equation. That should be straightforward. And then solve whatever's left over. Generally, that's going to be fairly easy to do after that. Now, since there's values we're not allowed to take the log of, remember we're not allowed to take the log of 0 or negatives, we do need to check all these answers. So let's go ahead and follow our steps. Move all your logs to one side, that's done. Everything else to the other, that's good. Condense into a single logarithm, I only have one logarithm here. Convert to the corresponding exponential equation. So 3 squared equals x plus 2. So 3 squared is equal to x plus 2. All right, so we get 9 is equal to x plus 2. That's nice and easy to solve. So we get x is equal to 7. Now we do want to check this answer. If you can do it in your head, that's fine, but you always do need to check. So let's plug this back in. 7 plus 2, does that equal to 2? Well, that's log base 3 of 9 equal to 2. So 3 raised to what power gives you 9? Well, that's 2. So we get 2 equals 2. So this does check. So that is our answer. Remember, make sure that you're checking because you can do all the work right and it's still not give you the correct answer. All right, I don't have enough room over there for the next example, so let me give us some more room here. Let's see, let's say if I gave us log base 4 of 5 plus log base 4 of x plus 3 is equal to 1. All right, this is a logarithmic equation because we have variables inside of our logarithm. Let's follow our steps. Move all the logs to one side. Everything that has a log is on the left. Move everything else to the other side. That doesn't have a logarithm, so it's on the other side. Condense into a single log. Now these are joined by addition, and according to our log properties, that means we're going to multiply those arguments together. All right, then we convert to the corresponding exponential equation. 4 to the first is equal to 5 times x plus 3. All right, this appears to be a linear equation, so let's go ahead and solve that. 15 goes to the side. So I get negative 11 is equal to 5x divided by 5. So I get negative 11 fifths equals x. All right, well, let's see what we end up with here. Let's see if we can check this. Sometimes the check is a little messy. So we got log base 4 of 5 plus log base 4 of negative 11 fifths plus 3 is equal to 1. So that's log base 4 of 5 plus, that's 15 fifths. That's log base 4 of this is negative 11 fifths plus 15 fifths would be 4 fifths. All right, now, normally at this stage you try to simplify this, but I don't know what the log base 4 of 5 is or log base 4 of 4, so we need to simplify it one of two ways. Either, since they're joined by addition, we can multiply these together, or I could break that up into two pieces because we're just joined by subtraction. I don't care which way you do it. I'm going to multiply them because that's the first one I see. So that's log base 4 of 5 times 4 fifths. When the 5 is reduced, this is log base 4 of 4. So 1 equals 1. So if you see, sometimes the check isn't as straightforward as just plugging it in. Sometimes once you simplify all the numbers, you might have to manipulate the logs a little bit to make sure that you do have the right answer. All right, so moving on, let's make it a little bit more complicated. Let's say we have log base 2 of x plus 1 plus log base 2 of x minus 1 is equal to 3. All right, pause the video, take a few seconds, see if you can solve this logarithmic equation. All right, so hopefully you had time to take a shot at this. Following our steps, we already have all our logs on one side, everything else on the other side. We're going to condense this into a single log. So this is log base 2 of x plus 1 times x minus 1. I'll put a bunch of parentheses there. You don't need all of those, of course. Then we convert to our corresponding exponential equation. So 2 to the third is equal to x plus 1, x minus 1, or 8 is equal to x plus 1, x minus 1. Well, this looks like this is going to be a quadratic equation, so I need to clear those grouping symbols. When you do that, that gives you x squared minus 1. And here we can actually extract the root, because all we have is something squared and everything else is numbers. So if I add 1 to both sides, I get 9 is equal to x squared. So x is equal to plus or minus square root of 9. And I'm just going to say, of course, that's plus or minus 3. Okay, so we have two possible answers here, so we need to check both of them. So let's check x equals 3 first. So that's log base 2 of 3 plus 1 plus log base 2 of 3 minus 1. Does that equal 3? Log base 2 of 4 plus log base 2 of 2. Does that equal 3? Log base 2 of 2 says, what do I have to raise 2 to get a 4? That's 2. Log base 2 of 2 says, what do I have to raise 2 to get a 2? That's 1. Well, that works. Right? 2 plus 1 is 3. What happens if we check x equals negative 3? That's log base 2 of negative 3 plus 1 plus log base 2 of negative 3 minus 1. Does that equal to 3? So that's log base 2 of negative 2 plus log base 2 of negative 4 is equal to 3. So at this stage, you can see that this can't work because we're not allowed to take the log of negatives, right? So x equals negative 3, x equals negative 3 does not check. Hold on, coming back. So we have to throw this answer away. So that does not work. So our only answer for this one would be x equals 3. That's why you have to check these. So once you plug that back in, if you end up taking the log of 0 or the log of a negative, that answer will not check. All right, let's do one more. Let's say I said log base 5 of x plus 3 plus log base 5 of x minus 2 is equal to log base 5 of 6. Again, let's get ourselves some room. All right, here's another one for you to try. Hit pause. See if you can solve this logarithmic equation. All right, if you're back, let's see. Step 1 says move all the logs to one side, everything else to the other. Well, this time I do need to move some logs around. I'm going to have to subtract log base 5 of 6 from both sides. So I get log base 5 of x plus 3, log base 5 of x minus 2, minus log base 5 of 6 is equal to 0. Now we want to condense all of this into a single log. It's all log base 5, so we'll end up with log base 5. Since we have pluses and minuses, we know we have a fraction. The ones that had a positive coefficient, the argument goes on the top. The logs with the negative coefficient, their arguments go on the bottom. All right, so now we convert to the corresponding exponential equation. 5 to the 0 equals all that. So 5 to the 0 is equal to x plus 3, x minus 2 all over 6. Well, of course, 5 to the 0 is just 1. And I don't like this fraction, so let's go ahead and clear the fraction. If we multiply both sides by 6, we got x plus 3, x minus 2 all over 6. On this side they cancel and we get 6 is equal to x plus 3, x minus 2. Well, that appears to be quadratic. So, well, let's distribute it out. So that's going to give me x squared minus 2x plus 3x minus 6, or x squared plus x minus 6. Move everything to one side. We get 0 is equal to x squared plus x minus 12, and then try to solve this quadratic. Well, in this case, that factors to x plus 4, x minus 3. X plus 4 is equal to 0, x minus 3 is equal to 0. So we end up with two answers to check here. We get x is equal to 3. All right, get rid of our steps. So we got a little bit more room to check here. Let's check x equals negative 4. So when we plug this in, I get log base 5 of negative 4 plus 3. Log base 5 of negative 4 minus 2. Does that equal log base 5 of 6? So log base 5 of negative 1, and you can see probably right there you can stop. As soon as you see that you're going to take the log of a negative, you know that this cannot work. So since we're not allowed to take the log of a negative, we can't do that and we can't do that, this answer will not work. All right, let's see if the 3 works. Let's check x equals 3. So we got log base 5 of 3 plus 3 plus log base 5 of 3 minus 2. Does that equal log base 5 of 6? So log base 5 of 6 plus log base 5 of 1 is equal to log base 5 of 6. Now that we got it down to one number, see if we can simplify anything. I have no idea what log base 5 of 6 is, but I do know what log base 5 of 1 is. Log any base, it doesn't matter what it is 1 because anything raised to the 0 power is 1. Log base 5 of 6. All right, so that checks, right? Log base 5 of 6 equals log base 5 of 6. So we do have one answer to this particular problem, and it is x equals 3. All right, so solving logarithmic equations, make sure that you're following your steps. Get all your logs on one side, everything else on the other side, condense into a single log, convert to the corresponding exponential equation, solve that brand new type of equation. Now, don't forget, you always have to check your log equations because you might end up with answers that don't work.